Now I'm recording. All right, so hopefully now you all see your whiteboard, right?
Yes, sir.
All right, I unmuted all of you, so do me a favor, mute yourself unless you want to talk, all right? All right, now, so let's do a really quick review of what we learned, right? So what we learned is different ways or different rules to use when we're trying to find derivatives. So we know that the first way we learned was using the definition of a derivative and using the limit definition. And then the other day, we learned a whole pile of stuff, right? So the first thing we learned was the power rule, right? And then we learned the constant rule. And then we learned the multiplier rule, right? And then we learned the sum and difference rules. And then we learned two trig rules, one for sine, one for cosine. And I think that's where we got to, right? Yes? Is that true? Hello? Somebody? All righty, good. So anybody have any questions? So that's what you were working on that homework assignment on page 772. Does anybody have any questions on any of that? All right, I didn't think so. All right, so from there, let's start adding. So what do these things do for us here? Well, not this one, right? What do these rules do for us? They make it really easy for us to find the derivatives of polynomial functions. So we don't have to use the limit definition, right? So knowing that, let's go add to it. So really quickly, what we're gonna do, all right? Let's do our trig functions again, right? So if f of x equals the sine of x, what's f prime of x? What's the rule? Who told me the rule? Go. What's the derivative? Cosine of x, yes? Hello?
Yes, sir.
All righty. If f of x equals the cosine of x, then f prime of x is what?
The negative sine of x.
The negative sine of x, all right? So all we're gonna do, all right, all we're gonna do is, everybody's clear on that, right? Nobody has any problem with that, right? Yes, no, maybe? Are we good?
Yes, sir.
All right, so now today I'm gonna add two more rules, right? It's really one rule, but it looks like two, right? So what we're gonna talk about today is derivatives of e and the natural log, right? We're talking about derivatives of e and the natural log, right? So let's start with e, right? This is super easy. And right now, remember, fellows, we're just introducing you to calculus. So we're not getting into proofs and everything. But if you memorize these rules, when you start doing the work next year, it's going to be really good for you, right? So if I have a function, e to the x, right? The way you find the derivative, right? You're going to tell me the rule, right? Right? F prime of x is simply e to the x. What's your rule? The derivative of e to the x is? Hello? What's the rule?
Drop
Look
the x.
Drop the x.
Whatever you got, e to the x, the derivative is e to the x. So what's the derivative of e to the third? E to the third. What's the derivative of e to the negative 7? E to the negative 7. You don't even have to do any thinking. Now, I'm going to show you really quickly why that makes sense. Ready? So there's my y-axis. There's my x-axis. And we know that the function e looks like this. all right? And this is what? E to the, what's the value of x there? 0. So what's anything to the 0?
0.
Anything to the 0?
0.
0.
1.
1. All right, so what that means is if I drew the tangent line at that place, right, e to the 0 equals 1, that means that the slope of that line would be 1. Now, if I go out 3, this number right here would be e to the 3rd, whatever that is, 2.71 to the 3rd, right? Well, what this says, right, if I have the function e to the x, the derivative is e to the x. So if I had e to the 3rd, what it would mean is if I drew the tangent line, the slope of that line would be e to the 3rd. That's all it means. So you don't have to do any thinking when you're finding the derivative of e to the x. It's simply e to the x. Can't be any easier than that, gents. Got it? Got it?
Yes, sir.
All righty. Second rule, natural log. If you find, right, so f of x, I'm sorry, hold on, let me write this correctly. If f of x equals the natural log of x. Okay. All righty. F prime of x, all right, the derivative is simply 1 over x. All right, 1 over x. All righty. So if you have f of x equals the natural log of 2x, well then f prime of x equals 1 over 2x. And we'll do some problems with that a little bit later on. Does that make sense? Hello?
Yes, sir.
Yes, sir.
Sir.
All righty. So those are just 2 rules that you're going to use. But those are not what we're going to really work on a whole pile today. But let's do one thing. Let's do something. So if I give you this, f of x equals negative 4 e to the x minus the sine of x minus 9. Well, what we're going to do is we're going to take all those rules we've learned, power, constant, multiplier, sum different, and trig, and natural log and base e, and we're just going to use them and find each. All right, so if I said to you then, f prime of x, well, this is easy. What do we know about e to the x? What's the derivative? What's the rule?
Negative 4EX.
It's itself. So you're going to get negative 4 e to the x. All righty. So now we're going to go over here. What's the derivative of the sine of x?
Cosine x.
Yeah, minus cosine of x. And then, of course, fellas, what's the derivative of any constant?
0.
0.
Yeah, and we never write 0, right? That doesn't make any sense, right? Yes? Hello?
Yes, sir.
Yes.
All righty. Does that make sense? It's kind of easy with e, right? It's kind of easy with e. Let's try another one. F of x equals 2e to the x minus 5 cosine of x plus 3. Well, if I said to you, find f prime of x, well, what would this become? Oh, e to the x is what? Itself, right? So 2e to the x, right? Now, be careful. What's the cosine of x? What's the derivative of cosine of x?
Negative sign, x.
Yeah, so -5 times negative, it's going to be positive 5 sine of x, yes? And then, of course, what's the derivative of any constant?
0.
0.
There you go. Does that make sense, fellas? Hello?
Yes, sir.
All righty. I'll get to a problem. I'll get to a problem with the natural log in a few seconds. Okay? Right now, I just want to go through this. All right, now today could get hairy. So now you got to pay attention, all right? Just pay attention real hard for about 15 minutes, right? We're going to talk about this thing called the chain rule, right? And we're not going to go crazy into detail with it, simply because that's not what we're doing. We're just introducing you to this stuff. But this is one of the most important rules that you're going to come across, right? So, does anybody remember what a composition is? Right? Does anybody remember what a composition is? All righty. A composition simply means you take some number, and then you take that number and you put it into a function. And then when you put it into the function, what happens? You get another number. You then take that number and put it into a different function, and then you come up with your answer. Does that make sense? So you end up with two different functions. So for example, let me clear this. If I said to you, f of x equals x squared, that's just one rule. So if I told you f of 2, all right, what's f of 2?
4.
4. But then you're finished, all right? Does that make sense?
Yes, sir.
But if I went like this, now all of a sudden, I got two things to do. F of x equal, if I said, tell me what f of 2 is, what's the first thing you would do there? Yes? Hello?
Yes, sir.
And you would get 5. Then what would you do with 5?
Square it.
You take 5 and square it. So there's two things to do. So there's really two functions. All righty. So what we're going to do today is use what we call the chain rule. And the chain rule is simply how you go about finding a derivative of a composition of functions. All right, so it's easier for me to show you how to do this by actually doing a couple of pretty easy examples. Ready? So try to bear with me and hang on for a couple of seconds. All righty? Write this down. F of x equals, okay, x cubed plus 3. All right. If I said to you, what's f prime of x? Okay. Tell me what the derivative is. Go.
X to the third, or 3x.
3x squared, right? Yes? And the derivative of a constant is simply what? 0. So that makes sense, right? You guys can handle that, right? Hello? Good. All right.
Yes, sir.
Let me change it up a little bit. Let me change it up a little bit. What if I went like this? What's the derivative? Go.
2x.
2x. Alrighty, so now you know how to use, now you have all the information you need in order to do what we call the chain rule, all right? So I'm gonna show you what it looks like, ready? X to the third plus 3 to the 5th. All righty. Now, don't freak out. If I give you x to the 5th, what would you do there?
Drop down the 5 and -1.
I would take the 5, move it out front, and then I would subtract 1 from 5 and get that. All righty. So here's what the chain rule is, right? Now, I'm gonna write some stuff on it. You don't need to go crazy here. Ready? This is one rule. This is another rule. So all I'm gonna do in the chain rule is do the two things, but I'm gonna do them in such a way, where I start with the outer and go to the inner. So I'm just going to treat this 5 and this bracket just like that x. So all I'm going to do is I'm going to take the 5 and I'm going to bring it out front. My function stays the same. And what does 5 become? 5 minus 1? 4. So the first thing you want to do in using the chain rule or finding the derivative of a composition of functions, first thing you do is do the outer function. And then what you're going to do is you're going to take the inner function and find the derivative of that and multiply it. So go. What's the derivative of this?
3x squared.
Done, right? Yes? So here's what we got. This is what we got when we did the outer function. This is what we got when we did the inner function. And now all you gotta do is multiply them together. Well, what's 3 times 5?
15.
15 x squared times x cubed plus 3 to the 4th. All righty? Does that make a little bit of sense?
Yes, sir.
All right, let's try another one. And all you're getting used to is doing the composition. So we're going to take the outer function. We're going to take the derivative of the outer function and multiply it by the derivative of the inner function. So all you got to do is pretend the expression inside the parentheses is just x. So try this one. F of x equals negative 3x to the 5th plus 1 to the 3rd. Now I did the 3rd. So we see, what's the first thing you're going to do? What's the first thing you're going to do?
Drop
Bring down
3.
We're going to take the 3 and we're going to put it out here, right? So it becomes 3. And instead of it being x, it's just going to be what? Negative 3x to the 5th plus 1, but not raised to the 3rd, but raised to the 2nd. Very good. And to that, we're going to multiply whatever the derivative of the thing inside the parentheses is. Go. Go. Hello.
Negative 15x to the 4th.
And what's the, yeah, and the derivative of a constant is simply what? 0, right? So now all I got to do is I got to take this number and multiply it by that number. What do you got? How
45.
there? Negative 45 x to the fourth times negative 3x to the fifth plus 1 squared. And there is your derivative of that using the chain rule. All right, are you starting to see anything that looks like it makes sense to you?
Yes.
All righty. Let's try another one. Ready? F of x equals negative 5x to the third minus 3 to the third. All righty. Well, really all you're doing at first is you're just pretending it says this. That's all. It just doesn't say x. So let's take the 3 and move it out front. And what's the exponent now?
2.
To the second power.
Good. And what do we have inside? We have negative 5x to the third minus 3. And then to that, we're just going to multiply what? Whatever the derivative of what's inside the parentheses is. Go.
Negative 15x squared.
There you go. And then we can just take this and multiply it to that times this. All righty. So that makes kind of sense, doesn't it? So all you got to do is be able to see the two distinct functions. All right? Does that make sense, guys? Let's give you a little bit of a trickier one. Ready? F of x equals the fourth root of negative 3x to the fourth minus 2. Now, this is two different functions, right? But it doesn't look like the other ones, but we can rewrite it. Rewrite that for me. Is that what it means?
Yes, sir.
Is that what it means, gents?
Yes.
Now it looks like all the other ones we did, right? Hello? Hello?
Sir.
Yes.
So the first thing I'm going to do is take my exponent and move it to the front. My function inside the parentheses stays. And what's 1/4 minus 1?
Negative 3/4.
3.
Thank you. And to that, we're simply going to do what? Multiply the derivative of that. Go.
Negative 12x to the third.
Perfect. All right, now we're just going to take that, multiply it by 1/4. What's 1/4 of a negative 12?
Negative 3. X.
X to the third times negative 3x to the fourth minus 2 to the negative 3/4. All righty. Does that make sense?
Yes, sir.
Does that make sense?
Sir.
All right, so it's not the most complicated thing in the world you're ever going to do. However, it does take a little bit of work. So really what you got to do is, this is what the rule says, right? If you're using the chain rule, hold on one second. The chain rule, right, simply means, right, you're going to find f of g of x, right? That's really what you're doing. It's a composition, all right? The way you find that is If you want to find f prime of g, it's f prime of g of x times g of x, g prime of x. That's all we've been doing. We've been breaking it down into two things. Does that make sense? Hello?
Yes, sir.
Yes.
All
Yes,
right.
sir.
Sir.
But I find it easier to do it when you use numbers instead of using letters. Let's make it a little more difficult now. Let's do some sine and cosine stuff, right? So f of x equals sine squared of x. Now, fellas, you need to understand that's how they write sine of x squared. So this is really the same as what? F of x equals the sine of x squared, right? Does that make sense? Those two things are exactly the same. So I got two different functions going on, right? I'm squaring something and I'm finding the sine of something, right? So I'm going to do the outer one first. So the 2 comes out here, yes? So f prime of x is going to be what? 2 times the sine of x, yes? To the
Yes, sir.
what? To the what?
Nothing. To the
To
1.
the first. 2 minus 1 equals 1, right? So now tell me what's the, so to that I need to multiply the derivative of the inner. What's that?
Cosine.
Cosine of x. Very good. So there's your answer. 2 sine of x, cosine of x. Not too bad, right? Not too bad? Hello?
Yes, sir.
Hello? All right.
Pretty good.
Next one. Try this one. F of x equals, well, it says the cosine cubed of x, but we know that's the same as what? Cosine of x cubed. All right, so what's the first thing we're going to do here? Which function are we going to do first? Cubing it, or which one are we going to find the derivative of first? Cubing it or cosining it?
Cubing it.
Cube.
Outside first. Ready? Good. Outer. This becomes what? 2 times the cosine of x to the what?
Sin.
Squared, yes? Hello?
Why is it 2?
What's the rule? 3x. What's 3 minus 1?
2.
Yep, don't forget, you got to remember all the rules, right? All right, what are we going to multiply that by? What are we going to multiply this by?
Negative sine x.
We're going to multiply it by the derivative of the inner function. Negative sine of x. All righty, good. So put it all together. Oh, hold on one second. Oh, my bad. Somebody said 2. Yeah, there you go. Should be 3, right? Go ahead. Negative times a positive? Negative, right? Hello? Hello?
Yes, sir.
Negative 3 sine of x times the cosine of x squared. Or you can put the 2 there, cosine squared of x, right? This and this are the same thing. Okay? Makes sense? Not too bad, right?
Yeah, it's good.
Yeah.
All righty. Now, so you've done a good few problems using the chain rule. So hopefully you're getting a little understanding of how to do it. Now, let's make it a little more difficult. All righty. Now we're going to use the chain rule with E. All right. Now, there's still two functions there, right? There's e, right? But there's also not raised to the x, but raised to the 2x. All right? Now, don't go crazy. I'm just going to teach you a rule just to get through the last last week and a half, right? So here's the rule when you try to find this, right? When you try to find using the chain rule, because you got two functions, right? So all you're going to do is, what do we say e to the, what's the derivative of e to the x?
E to the X.
It's e to the x. So all you got to do this, ready, is take whatever this expression is and copy it. And then multiply it by the derivative of that expression. What's the derivative of 2x? Bring the 1 out, right? Bring the 1 out. What's 2 times 1? Oh, I lost it. Hold on.
Shoot.
Huh? Let me rewrite that. Sorry about that, fellas. F of x equals e to the 2x, right? Doesn't say e to the x, says e to the 2x. So the first thing you do when you have e in a composition, right? All you do is copy down what it is, all right? Because e to the x, the derivative of e to the x is e to the x, right? To that, you're going to multiply the derivative of the exponent. So if I had just given you this and said, what's the derivative? Well, 2x to the first, 1 comes out. That's 2 times, what's x to the 0? What's
1.
anything to the 0? Yeah, what's 2 times 1? 2. So there you go. Copy down what you have, right? And then take the derivative of that. And then what do you got? 2e to the 2x, right?
Yes, sir.
Try this one. Same rules, ready? The function of x equals, it looks really complicated, fellas. E to the 3x to the third minus 4x. Well, if I give you that, that looks really super complicated, but it isn't. It's a composition. So what's the first thing we do with the e? What did we say the first thing to do was?
Copy it down.
Copy it. E to the 3x to the third minus 4x. And to that, we're going to multiply what?
The derivative
The
of the
derivative of that expression right there. Go. Go ahead. Take that first term. Rules you learned the other day.
Drop the 3 down, so 9x 2.
9x squared. Go ahead.
minus 4.
Minus 4. There you go. Done. That's all you gotta do. Make sense? Yes or no?
Yes, sir.
Coach, where we get the 9 from?
3 times 3.
Okay, never mind. All right.
Let's not forget the rules we learned the other day. All right. Make sure you gotta remember the rules that you learned, right? You still gotta remember the rules you learned from math in 4th grade, don't you? Oh, you hungry, Dylan?
Yeah, I got some fly.
Yeah, whatever.
I'm listening, Coach.
All righty. Now I'm going to throw some natural logs in there. Ready? F of x, another problem here. Ready? F of x equals the natural log of the sine of x, right? So notice we didn't say the natural log of x. We said, so this is different, right? This here is totally different than that. This is a composition, right? It's the natural log of not x, but the sine of x. So there's two things you're doing there. Ready? So let's just do what we learned. Ready? We're going to do the outside first. All right? So the first thing we're going to do, right? We're going to do what?
1 over sine of x.
Very good. We're going to do, so f prime of x is going to be, we're going to take the natural log not of x, but of the sine of x. And the rule simply means this. Now, the second part of doing the chain rule is to multiply it by the
Cosine,
derivative of that. What is that?
cosine x.
Cosine of x. And then, of course, you can do this, right? Agreed? Hello?
Yes, sir.
Yeah.
All
But
right.
wouldn't it also equal tan?
That would be yes. But that's fine.
Okay.
We're just telling you how to find the derivative, right?
Mhm.
All righty. Let's do one more with this. F of x equals the natural log of the square root of x. All righty. Let's break it up into its two parts, right? So we got f prime of x. Well, what's the first thing we're going to take care of? We're not going to take the natural log of x. We're going to take the natural log of radical x. What is it? That is.
Radical x.
Yep. And then to that, what are we going to multiply it by? What's the derivative of that? Well, what do we know x, the square root of x is the same as?
1 over 2.
Yep, x to the half, right? So what is that? Move the half to the front. Yes? And that becomes x to the what? What's 1/2 minus 1?
Negative 1.
Negative 1/2. All righty. Now let's see what we can do with this one. Ready? Well, if I wanted to make the negative 1/2 positive, where would I put it?
In the denominator.
Yep. I can move that down. But what do I know x to the half is?
To radical.
Now you're just doing algebra. What's 1 times 1?
1.
What's this times this?
Just x.
Well, you have a 2 there, right? So 2 times 1 is 2. Radical x times radical x is x. Makes sense, right? Not too bad, right?
Yes, sir.
Hello.
Yes,
Hello.
sir.
Yeah, that's a lot of work, fellas. Do you think you can remember all those rules? Hello.
I'm not sure, sir.
You're not sure? What do you mean you're not sure?
I could try.
Who is that? Does that sound like Mosweta?
No, it's me, Arthur.
Arthur. All righty. Let's do one more. Let's do one more and see how good we're at. Let's try this one. I'll give you. Let's do 2 more. Let's do an easy one, then a more difficult one. F of x equals radical negative 2x squared plus 1. All righty. So what's the first thing you're probably going to do, fellas? Is that what you would do first?
Yes, sir.
Hello?
Sure.
Yeah, that's what I would do first. Because now I'm just going to use my rules. All right? Now I'm just going to use my rules. I want to do the outer and then the inner. So I'm going to take my little half, bring it out front, yes? but it's not of x, it's of what's inside the parentheses. And then I subtract 1 from a half. What do you get when you subtract 1 from a half?
-1.
-1/2, right? And to that, I'm simply going to multiply the derivative of the inner. What do you got?
Negative.
Negative 4x.
Beautiful. And now you can just take this and multiply it by that. What do you got? What's a -4 times a half?
Negative 2x.
2x.
And don't forget the x times -2x squared plus 1 to the -1/2. And that's what f prime is. All righty? Take the derivative of the outer and multiply it by the derivative of the inner. All right? All righty. Let's do one more, a little more complicated. Not crazy, though. Take the derivative of the outer and multiply it by the derivative of the inner. Off you go. See how good you are at it. Take the derivative of the outer and multiply it by the derivative of the inner. How many people got that far?
Yes, sir.
Does that make sense? Now, what could this become?
2x over x squared.
Yes? Does everybody understand this part right here? The derivative of the outer times the derivative of the inner. Yes or no?
Yes, sir.
Hey, fellas, that's about, I don't know how else to teach the chain rule, because if I start telling you f prime of g prime of x and all that, like your head might blow up, right? So the way I found the easiest way to learn how to do it is to do it doing the problems. And then after a while, it sort of becomes like second nature to you, right? So if I give you another one, nice easy one for you. Did I just give you this one? Yeah, I just gave you that one. Now I'm starting to lose my mind. All right? All righty. Does that make sense to you guys?
Yes, sir.
Hello?
Yes, sir.
Hey,
Yes, sir.
remember, it's the derivative of the outer times the derivative of the inner. If you get confused, fellas, this is all you got to do. Just go like this. Like, write whatever you got, and instead of putting a thing inside the parentheses, just leave the parentheses blank until later, and then you know you would go like this, and then you'd subtract 1. And then put back whatever's in there, and then after you do that, multiply it by whatever the derivative of that is. Not a big deal. All righty? So now, I put in your Dropbox a little worksheet working on derivatives using all of the rules, all right? So now here's what we know. We have limit definition, right? We have power, constant, multiplier, sum difference, we got trig, we got natural log and E, and we got the chain rule. That's a lot of stuff. All righty? So the most important one, like a really important thing that you're gonna have to know how to do, fellas, you have to know how to use the chain rule. You have to know how to find the derivative of a function of a function, all right? And it simply means derivative of the outer times the derivative of the inner. Does that make sense? All righty. That's about all you got for today, Chiefs. All right. Anybody have any questions?
When is the thing you put in the document?
Friday at 11:59 p.m.
Awesome. Thank you, sir.
All righty. All right. I got office hours today at 2. I forgot about them yesterday. I was doing so much work. All right. I did office hours today at 2, but I also have them tomorrow on Friday. I have them tomorrow at 2 and then Friday morning at 9 if you're getting stuck. All right. Does everybody have it? Everybody good?
Yes, sir.
Yes, sir.
Everybody?
Yes, sir.
Yes, sir.
All righty, guys. You can have a good day then.
All right, coach.
See you.
All right.
Thank
all
you,
the best.
Coach.
All the best.